If you already know how to solve simultaneous linear equations using the substitution method, then that method really is all you need because you can solve any simultaneous equations that way. The elimination method is really just like the icing on top. It's a different method that you can use, which is sometimes quicker and easier. Other times it's not though. Now, the whole idea with the elimination method is that we're trying to eliminate one of the pronumerals really quickly and easily. And this method works best when you've got a set of equations that might look something like this. Perhaps neither of the pronumerals is by themselves, and when both of the equations, let's say this is equation 1, and equation 2 could be something like x minus y is equal to, I can put any number here, let's say minus 30. All right, I'm adding two numbers, they make 6, but when I subtract them, I get minus 30, and I've got to work out what x is and what y is. Neither of the pronumerals is on their own. Now, the whole idea with the elimination method, it's like we're doing a great big addition algorithm or a great big subtraction algorithm. When I say algorithm, I'm taking you back to primary school for a second. Remember when we do something like this and we add in columns. And when you learn how to do this, remember how you had to keep the ones column and the tens column and the hundreds column lined up? And same if you're subtracting. Well, same thing here. We're going to treat the x's and the y's and the numbers like 3 columns and literally add everything together to make a third line, or subtract one thing, the top line, from the bottom line. Now, why would we want to do this? Well, we're trying to eliminate one of the pronumerals, because if you've got two pronumerals here, it's not enough to work out what each one is. X plus y equals 6, or it could be 1 and 5, it could be 2 and 4, it could be 1.5 and 4.5. There's infinite number of answers for each part of this question. So we're trying to eliminate one of the pronumerals so that we've just got one letter in our equation and we can solve for it. Now, the whole idea of eliminating is not new to us, because when we're solving linear equations, haven't we learnt that if we want to get rid of something, let's say we've got an equation like this, and we want to disappear the plus 1, what do we do to get rid of it? We do the opposite of plus 1, which is minus 1, and we subtract 1 from both sides. We can do that to the 2x. We could subtract 2x from both sides. We could subtract 5 from both sides. We can disappear anything from an equation by just subtracting it. So if you've got 2x and you don't want that there, you can minus 2x. Now, if we are going to look at whether we need to add or subtract the equations, here's the idea. If I add the equations together, x plus x is going to give me 2x. And y plus minus y, well, if you have y and then you add minus y, it's actually just y minus y. You're going to get nothing. Okay, so there's two strategies I can use with this particular one. Others are going to have one strategy or the other. I'm going to add the two equations together here and see what happens. X plus x is 2x. Y plus negative y, that's nothing. They disappear, so I've eliminated them. And 6 plus negative 30, that's the same thing as 6 minus 30. It's negative 24. And again, if you struggle with the negative numbers, use your calculator. Now I've got 2 times something is negative 24. I can divide both sides by 2 here. Divide this side by 2, divide this side by 2, and I can see that x has to be negative 12. Now I can sub that into either equation so that the end part of this method, elimination, finishes just like the substitution method does. Once you've found one pronumeral, you sub that back into either equation and you find the other pronumeral. So to finish it off, let's rewrite the first equation, but we won't write x, we'll write negative 12 plus y is equal to 6. Now to get the y on its own, I need to disappear this minus 12. How do I do it? Add 12. If I add 12 to one side, I have to do it to the other. Now the y will be by itself because these guys will cancel each other out, and 6 plus 12 is 18. So now I've found both answers. If I add these two numbers together, I get 6, and that's correct. And if I do minus 12 minus 18, I do get minus 30. So I've found the solution here. Now, another way that I could have done this, instead of adding the equations, I could have actually, with this one, taken them away. So if I do equation 1 minus equation 2, treat it like a great big subtraction algorithm, x minus x gives me no x's at all. So that first column would have nothing in it. y minus y. Let's just think what that looks like. We've learnt earlier in the year that if you subtract a negative, that's the same thing as adding, isn't it? It's the same thing as that. And y plus y, that's just 2y. So this column here would give me 2y. And if I do 6 minus 30, again, that's the same thing, 6 plus 30, I get 36. Halving both sides. Why am I halving? Because this y has been multiplied by 2. So if I divide it by 2, it'll be just itself, y. But if I've halved this side, I need to halve that side as well. You can use your calculator for that if you need to. So this method of subtracting has actually got me the answer to the y's first. I eliminated the x's. How did I do it? Well, I had x and I had x, so if I took them away, there was no more x's, but there was still some y's, and I could figure out what the y was equal to. Now I can sub that back into either equation. Let's rewrite this one, but instead of writing y, we'll write what y is. And now to get the x by itself, we need to disappear this annoying plus 18. We can take it away from both sides. Now I've got the x on its own, and 6 minus 18 is minus 12. So doing it that way got me the y first and then the x, but I still got both of them in the end. Now, here's some notes you might want to write down about how to do this. The first step is actually to check that both equations have their corresponding parts lined up. So the x's, the y's, and the numbers. And if they don't have that, then you can rearrange it so that they do. Also, check that they have a coefficient. Now, a coefficient is just the number that sits in front of the pronumeral or the letter, isn't it? So check that they have a coefficient of a matching pronumeral, so the x's or the y's, in common. In other words, if you're looking at the x's, it would need to be 2x and 2x in both of them. It needs to be the same number sitting in front of the x's. Now in this case, this was 1x and 1x, so tick, it had that. Or, say, with the y's, it needs to be the same number of y's. And again here, ignoring the signs, plus and minus, this is 1y, isn't it? And so is this. So I actually was spoilt for choice here. Both the x's and the y's had matching coefficients. But you need that. Why? Well, there's no point, if you had, this was, say, if this was 3x and this is also 3x, then if you've got 3x minus 3x's, the x's disappear. And that's what you want. You want to disappear something. If you had a different number on each one, let's say this was 5, then doing 3x minus 5x or 3x plus 5x, it's not going to disappear those x's, is it? So to disappear one of the columns, you need to have that number being the same. And if it's not, you can adjust it. We'll have a look at how to do that in a minute. If they don't have this situation, rearrange it so that they do. You might need to rearrange one or both of them. We didn't have to rearrange this example. Then, here's what we did. Add the equation if the signs of the matching coefficients are different. Okay, so here the y's had different signs, didn't they? One was plus and one was minus. So to disappear the y's, we had to actually add the equations together. That's what we did first. Or subtract the equations if the signs are identical. So here the signs are identical. So if we do one of them, take away the other one, they disappear. Then solve for one pronumeral and sub that into either equation to solve for the other. In this example, I can see straight away that the x's have the same matching coefficient of 2. The y's have got 1 and a 3, so that's no use to me. So I'm going to work with the x's here. I'm going to eliminate those. Now, let's stop and consider whether we need to add the equations to do that or subtract them. Well, if I add 2x plus 2x, I'm going to get 4x. That hasn't disappeared the x's at all. But if I subtract them, 2x minus 2x, that gives me nothing, and that's what I'm after. So let's do equation, well, we can do either one minus the other. I'm actually going to be a bit cheeky here and do the second equation minus the first one. Why am I doing that? Well, I can see that I've got bigger numbers of y's on this second equation and bigger numbers here than I have on the top line. And to me, it's simpler to do 13 minus 7 and 3y minus y. It gives me nice positive answers. So I'm going to do equation 2 minus equation 1. Bit tricky, but I can work this way. All right, 2x minus 2x is nothing. So I've got nothing in my first column. 3y minus y, that's 2y. And 13 minus 7 is 6. All right, 2 something's a 6. 2 3's a 6. Y must be 3. And our other method we can use there is halve this side and halve this side. Now we need to sub y equals 3 back into either equation. Let's sub it into 1. All right, we need to rewrite this, but don't write y, write 3. 2x plus 3 equals 7. And now let's get the 2x's by themselves. We want to disappear this plus 3 by subtracting 3 from both sides. That will give me 2x on this side, and 7 minus 3 is 4. Now I can halve both sides to get the x on its own here, and x is 2. So x is 2, and y is 3. I can circle my answers there. And if I sub x equals 2 and y equals 3 into either of these equations, it should make both of them true. Now this example is trickier because I've got a 2 and a 3 for my x's, and I've got a 1 and a 2 for my y's, so none of these are ready to go. So we can do what we talked about, which is we can adjust one or both of the equations if you need to, but here I can see that I can adjust one equation so that I can get that situation that I'm after. Now the easiest one to work with is going to be the y's, because here I've got 1 y and here I've got 2. So if I doubled this one, it would be perfect, okay? But just as with any seesaw, if you double something on one side of the seesaw, you've got to double everything on the seesaw. So that means we've got to double the 2x, we have to double the y, and we have to double the 9. And that should still keep it balanced after all. So what I'm effectively doing here, I'm making equation number 3, which is like equation number 1 in disguise. So if I double, and the way I'm going to make it, I'm going to do equation 1 times 2. I'm going to double everything. All right, what's 2 lots of 2x? 4x. Minus 2 lots of y, that's 2y, is going to equal 2 lots of 9, which is 18. So now I'm going to work just with these two equations, almost like I've changed the question now to suit myself. And solving these two will be just like solving those two, because number 3 is really just number 1 in disguise with everything doubled. Now I've got my matching coefficients. I've got the 2's here on my y's, so I'm ready to go. I need to consider, do I need to subtract the equations from each other or add them? I need to add them, and that's because the signs are different here. So if I do 2 plus minus 2, I get 0. So I'm going to eliminate my y's by doing that. So I need to add equation 2 and equation 3 together. So complete your columns. 3x plus 4x is 7x. Just checking 2y plus negative 2y, that's nothing, so I'll get nothing in that column, equals 17 plus 18, that's 35. All right, 7 somethings are 35. I know that 7 5s are 35, but if you weren't sure here, remember that strategy. Divide, instead of multiplying by 7, divide by 7, and that will give you x by itself, and 35 divided by 7 is 5. So I've found one of my pronumerals. Now I need to sub this back into any of these 3 equations, it really doesn't matter which one, to find y. So let's sub into 1. Notice how when I'm naming my equations, I put that in a circle. So I'm going to write this equation out now, but instead of writing x, I'm going to write 5. So I've got 2 lots of 5, that's 10, minus y equals 9. Well, 10 minus something is 9. The something has to be 1, doesn't it? So y is equal to 1. Now, this method was a bit tricky in that I had to rewrite one of my equations before I was able to use the elimination method, but you'll see the working there is really still quite quick and easy. And the advantage of elimination is that it can be a lot quicker than substitution when you've got your things lined up and when you've got matching pronumerals, or it's really easy to get matching pronumerals and you don't have any of your pronumerals on their own. Now, for those in year 11 or 12 who might be looking at simultaneous equations where one of them is actually a parabola or has an x squared in it, that's going to be your giveaway. This method is not the one to choose. You need to use substitution for those sorts of questions.